The first of two crucial vehicles for ALMA, the Atacama Large Millimeter submillimeter array, rolled out of its hangar and passed successfully a long series of tests. The ALMA transporter is a rather exceptional vehicle, supported by 28 tyres, that is 10 metres wide, 6 metres high and 20 metres long, weighs 130 tonnes and has as much power as two Formula 1 engines. These specially designated transporters are necessary to move the ALMA antennas, each weighing more than 100 tonnes. When completed on the high-altitude Chacnantor site in Chile, ALMA is expected to comprise at least 66 antennas, which can be placed in different locations on the plateau, but which work together as one giant telescope. Changing the relative positions of the antennas, and thus also the configuration of the array, allows for different observing modes, comparable to using a zoom lens on a camera.
The ALMA radio telescopes will be assembled at an altitude of 2,900 meters. The transporter then will bring the antennas up to the observatory located at 5,000 meters. Furthermore, we do have various configurations of the observatory, and the transporter will move the antennas from the compact configuration of about 100-200 meters diameter to the extended configuration, which stretches up to 15 kilometers.
Given their important functions, both for the scientific work and in transporting high-tech antennas with the required care, the vehicles must live up to very demanding operational requirements. Each transporter has a mass of 130 tonnes and is able to lift and transport antennas of 115 tonnes. They must be able to place the antennas on the docking pads with millimetric precision. At the same time, they must be powerful enough to climb 2,000 metres reliably and safely with their heavy and valuable load, putting extraordinary demands on the 500 kilowatt diesel engines. This means negotiating a 28 kilometres long, high-altitude road with an average slope of 7%. Finally, as they will be operated at an altitude with significantly reduced oxygen levels, a range of redundant safety devices protect both personnel and equipment from possible mishaps or accidents.
In order to operate the transporter at the ALMA site, engines with 1,700 horsepower are installed. At this high altitude, the power output of the engine is limited to 860 horsepower. All the components have been checked to meet the requirements at these extreme conditions. The human factor is also considered. For example, the backrests of the driver's seat are shaped to allow the driver to wear his oxygen tank during driving.
ALMA will observe in the millimetre and submillimetre wavelengths, and this means the atmosphere above the telescope must be transparent. This requires a site that is high and dry. For this reason, ALMA is installed at the 5,000 metre high plateau of Chacnantor in the Atacama Desert of Chile, probably the world's driest, the next best thing to outer space for these observations.
The biggest challenge was the environmental condition at ALMA site, with an altitude of 5,000 meters and a drive distance of 28 kilometers uphill, with a maximum slope of 10%. To drive this road downhill, we have to install a special brake system. Also, the transporter is very user-friendly to take into account the reduced capability of the operators at this high altitude.
ALMA will be the forefront instrument for studying the cool universe, the relic radiation of the Big Bang, and the molecular gas and dust that constitute the very building blocks of stars, planetary systems, galaxies, and life itself. The ability to move antennas to reconfigure the array is vital to fulfilling ALMA's scientific mission. The operations plan calls for moving antennas on a daily basis, to provide the flexibility that will be such a big part of ALMA's scientific value. The ALMA transporters are therefore most important, and the present delivery is a significant milestone.